We ready to go? Christine? Are we live? Greetings, everybody. Thanks so much for joining us for this Performance IQ webinar. We're focusing today on the very hot subject, in fact, something of a holy grail in gaming, of performance automation. I'm Michael Baylor, I'm the CMO of GameBench, and I'll be hosting today's session. For those of you who are new to us, I'll give the very briefest possible intro to get us into our conversation ASAP. And if you want more background, of course, please do check our website at gamebench.net. So, for 10 years now, GameBench has been a pioneer in game performance management. We specialize in the scientific measurement and optimization of all experience tech across every form of rich media. And we serve two complementary markets. On one side, we provide performance analysis, benchmarking, and monitoring services worldwide to ISPs, mobile operators, and device manufacturers. And we also deliver performance testing and monitoring software and services to leading game developers and publishers. As you can see from this chart, the approach has won us some market-leading clients across this entire ecosystem. Right, that's the corporate bit over and done with. My colleague, Andrew Fester, GameBench Product Manager, will be opening today's presentation, and we're joined by Shane Evans and Hunter Golden of GameDriver and Vincent Lussenberg of Source Labs. Before I hand over to Andrew to kick us off, a couple of points about how we're running today's session. You'll have plenty of questions, we hope, and we'll be responding to them as we go along. So we won't be waiting until the end. Please put your questions into the chat as soon as you like, and we'll aim to bring you live into the discussion to discuss them with the panel. There'll be several breaks in the course of the hour in between sections, so we'll be responding to those questions during that time. So get your questions into the chat and be ready to become an instant panelist. We'll be wrapping up promptly on the hour, as we always do. And if you don't get a chance to discuss your question with us here, please do contact us after we close. We'd love to hear from you. Right, that's quite enough from me. Andrew, over to you.
Thanks, Michael. So as Michael said, I'm the product manager at GameBench, and I want to talk to you about the problem of automation. So first of all, why do we even want to automate? Well, there are many reasons. One being that, we want to scale up. Maybe we want to make testing more cost effective. Maybe we want to take advantage of some time outside of normal working hours. And maybe I just want to see repeatable data week in, week out, so I can identify when something changes. So we now can see that there is something that we want to address. So where would we start? Well, first of all, if we're going to start scaling things up or automating things, we need to be able to automate the gameplay. Potentially you could inject key presses, or you could do something a bit more effective, like controlling game objects in an automated fashion. And this is where GameDriver will step in and guide you through what they can offer in this area. Second of all, we want some testing data, some performance data. GameBench is originally started with manual tooling, where an individual would sit in front of a test console and would test a session, one-to-one relationship between device and person. We're going to scale this up. We're going to need some sort of performance metrics integrated into the product. And this is where GameBench step in. Thirdly, we're going to want access to more devices, simultaneous devices, potentially something that's offsite. And we'll also want to know when things go wrong with the test runs. And this is where Source Labs can step in and provide us with a solution. I'd like to hand over to Hunter to go through the GameDriver, or Shane, sorry.
Thanks, Andrew. And so I'm going to take over sharing here, and I'm going to talk a bit about GameDriver and what we do before I hand it over to Hunter to give a demonstration. So GameDriver is an automated testing solution for gaming and XR applications. So we set out to provide the same level of automation that the enterprise software industry has enjoyed for several decades now in a space that really was lacking tools for testers. And so we started with Unity. We're building support for Unreal and Godot, which are hopefully coming very soon. And We provide a out-of-the-box scalable solution for testing across Windows, Mac OS, iOS, Android, and really anywhere that the game engine is able to go, and provide multi-host, multi-threaded capabilities so that you can do very complex multi-user scenarios as well. We provide a powerful object identification capability via a language we call hierarchy path, which is modeled after XPath for anyone who's familiar with that for Selenium testing. And it's a very simple, intuitive API for developers and testers that allows you to control game objects at replay. You can provide user inputs, simulate devices like VR headsets. We can interrogate objects at runtime so that we can reach into the game that's being tested and query objects for their values and properties. We can also change those properties at runtime. And lastly, we can run any command that's attached to any game object, whether it's private or public, which Hunter is going to give a demonstration for here in a moment. If you're interested, of course, check us out, and we're happy to take any questions on how any of this works. Hunter?
Hello. Yes, I have a short demonstration prepared, so I'll go ahead and pull up the video here.
Take over sharing, of course.
Yep. Can everybody see that okay?
Yes.
Perfect. Yeah, so as Shane said, we've got a brief little demo prepared today. So we're going to start off here in the Unity editor, and I'll just show you how easy it is to kind of integrate GameDriver, right? So we're just basically a game object sitting within the scene, and we've just got our script attached, and that allows us full access into anything we could possibly want on the Unity side of things, essentially. So that would come as a package and would be imported. So we'll jump briefly over to the code here. So we can see that we can run in the editor and also in a build. As you can see, the IDE mode is selected, as we'll be showing the first demonstration in the editor, and then how it integrates in a Sauce Lab environment. So we've just got a few tests set up here. And as you can see up there, that's just what's connecting to our agent here from our test. Now we use NUnit to run this test. You can use whatever you'd like, but just for demonstration purposes, what you're looking at is NUnit. So what you're going to see here is our first test is making a few calls into the game here to check whether some buttons are active. And if they're active, go ahead and click those buttons. So that'll get us through the UI here in the first test. And then we'll assert that the scene has changed when we click those buttons correctly. And then in our second test, this is going to be what's responsible for moving our boat around the map. So it's a boat racing game we'll be showing, and it'll be showing the boat moving to the different checkpoints that we can see here. So the logic's pretty simple there, but it's to show that we are able to access objects within the Unity hierarchy, and we use a language called hierarchy path to do that. We can also call, public methods in Unity, and we can also call methods on game objects and scripts, as Shane briefly touched on there. So our test will run through the level, and then we'll disconnect from the agent, which is important to give the player access back to the game so that they can play and continue testing from there. So we'll go ahead and run these tests here in NUnit, and we'll jump back into the editor, and you'll see everything happening pretty quick here. So we saw that's all GameDriver. I'm not doing any input on my side here. This is all test automation. And you can look in the top left, there's a little UI that just gives some information that our client is in fact connected. It might be hard to see on some screens, and we're off to the races here. So we can see our boat, the player, driven entirely by GameDriver. It's going to head to the first checkpoint, and then he'll continue to head to the next checkpoint. Now, for the sake of this presentation, I'm not going to show the whole thing, so we'll cut off here in a second, and we'll jump into Sauce Labs, and I'll show you how we can integrate GameDriver with their environment and test on their devices. So we'll come over here. We'll pull up in our mobile app setting here. Now, I've already uploaded my build, our APK here, and we'll select the device. We're going to select a private device here. And Vincent, I don't know if you wanted to pass a quick note about that.
Sure. Yeah. No, this is very helpful. So this is Vincent from Sauce Labs. I'll introduce myself later. But this is a great screen to see all the different devices that would be available in the Sauce device cloud. So it's a combination of private devices, which means that it's a device for your organization only. That means that no one else can access it. So you can do more administrative stuff, such as virtual USB connections, which is what Hunter will demonstrate just now. But there's public devices as well, so that means that it's shared with other Sauce Labs users. After each time that it's used, it's being cleaned afterwards. But that allows you the ability to test on many different devices and platforms, both for iOS and Android, going back many Android versions. So you can make sure that your game works on older phones as well. So yeah.
Perfect. Thanks so much for that, Vincent. So we'll continue on. So we can see what that looks like. We've selected our phone that we're testing on Sauce Labs environment. I'm just going to rotate the device. We skipped around some installation stuff there, so we can see our game is up and running. Now I'm just going to be running a few quick command lines, like Vincent had mentioned, to connect to the virtual USB, and that's going to allow us to send the traffic from our tests to their phone so that we can test it on that. So you can see there, we found the phone that I'm loaded on and tested. So now I'm just going to run a quick command to connect to that. And then after I run those commands, we're just going to forward some of the traffic. So there are a few steps involved, but it's a very simple process once you kind of get the hang of it. Perfect. Now here you'll see us connecting to it and then forwarding the traffic. Then all that's set. Now we're going to run the exact same test that we ran in the IDE, but now it will be in the standalone mode because this is a build that we're testing on. So all I'm going to have to do is just change this, make sure that I've changed this correctly. We'll save this, and the test should perform the exact same way on this device. So we'll hit run. We'll cut back into the game here, and we should see everything click through the UI the same way again. We'll be able to verify that we're connected in the same way. Go through our little loading screen here. And then while this is just kind of running the test and finishing up, I'll give Vincent a chance here if he wants to set up, and he can tell you more about how we use all this data that we're getting from these test runs in Sauce Labs and what we can do and gather from that information. So thank you, guys.
Cool. Thank you so much, Hunter. Let me go ahead and steal the screen share.
Of course.
Cool. So everyone's seeing my screen here? All right, excellent. Cool. I'm going to first introduce myself. Hey, I'm Vincent Lustenberg. I'm a technical product manager for Sauce Labs. I'm responsible for the SDKs that we're looking at today. For the Sauce Labs side, Sauce Labs Backtrace, more about that later, as well as gaming vertical. So I want to introduce Sauce Labs real quick, and Sauce Labs does a bunch of things, but I will focus it very much on what we're doing at the webinar. So what Sauce allows you to do is scale your testing by providing both real devices as well as virtual devices, so emulators, on our infrastructure, so you don't have to scale it yourself. We support various different modes of integrating, and you see a little testing pyramid here, where we generally see with our gaming customers that the vast majority of the testing that they're doing is in the bottom of this pyramid, emulator and simulator testing, where you're mainly focusing on your gameplay. Does my level work? Is my level too easy or too hard? Are there specific problems on a map where you can get stuck? These things you tend to be able to test that on emulators and simulators just fine. There are certain things, if it comes to device compatibility and performance on devices, where you kind of have to run it on the actual device. Of course, if you're running on an emulator, it actually runs on your computer CPU, so it's just not representative of what the performance actually would be on that device. So what Sauce offers is the ability to connect to real devices that we have in a data center, so you can deploy your APK or your IPA, your iPhone app to that, and test it. What you see in this pyramid is that generally you can just get away with testing that on public Wi-Fi and network simulation tools. In other words, that device is not connected to your actual internal network. There are certain situations where you want to do that as well. So we have some customers, for example, that have 3D applications that run within a corporate network. So you have the ability with Sauce Real Device Cloud as well to connect into your network itself as well. So that means that the device will be still in our data center, but it would be connected through VPN to your own network. So just Separated, we talked about it shortly while Hunter was queuing up the demonstration as well. So Sauce Labs has two major products that are relevant for what we're talking about today: the private cloud and the public cloud for real devices. I should mention. So these real devices, if you have the private cloud in your subscription, that means that you have a certain number of devices available to you. Those are just used by your organization, and it means that you can do a lot of things on that, such as make the virtual USB connections to run automation. For the public cloud, these are more shared devices where you have a little bit less privileges to work with, but you can install your app, you can interact with it, you can run Appium tests on it as well. You wouldn't be able to override network settings the same way as you would with private devices. And through these settings, of course, the private devices and the public devices have a different price tag. But if you think back on that testing pyramid, you can use these different options to run all your tests in like the appropriate ecosystem at the right cost. These clouds are also available in different regions. So we have them in US and in Europe and stuff like that. So long story short, Sauce Labs allows you to scale up all that testing that you want to do, either manual or automated, to the cloud, and allows you to do device compatibility testing without you having to maintain old iPhones that you can downgrade to previous versions. We can take the hassle out of that. I'm also here representing Backtrace. Backtrace is a Sauce Labs company, and it's focused on the error capture, prioritization, and resolution, what we'll take a look at really quickly as well. So during QA and playtesting, you are receiving errors and maybe even crashes during automation. For an automation framework, it's really hard to find out what exactly went wrong, because generally automation frameworks connect to the game from the outside rather than the inside. Our SDK that is embedded into your game, just like the GameBench SDK, actually, like I said, is embedded and can capture that information and important metadata as your game is crashing or experiencing some errors. So we're going to see the test that Hunter just ran, what kind of results we get out of that if we go and take a look at the test results after the test finished on Sauce Labs. So I'm going to switch and show you a video. So we're going back to that screen that Hunter just saw where he just ran his test run. And what we're going to see here is that during that test run, it was recorded that there were interactions with this game. So you have overview of metadata of how that game was started, what the file name was, what the device was. All that information is available to you, as well as a video. So you have the video of the exact same thing basically that Hunter was showing. So that's captured on the device, is persisted, so you can always download it. You have log files for network requests that your app might have done, as well as everything that just happened on that individual device. So that's all available. I was talking about exception and error capture. On the bottom, we see a couple of different tabs. First of all, we have the network, which will show any network request. We have some device vitals, which do not contain the amount of data that GameBench would show, but give you some information on what the phone has been doing, and error and crash reporting. So what we see here is that 2 errors were detected during the running of the game. So Sauce Labs is connected to a backend where all these errors are being sent automatically as that game runs. And if there's errors, hangs, or crashes, you see that automatically in context of that test run. So let's say that during this test run, maybe the application crashed. GameDriver wouldn't have been able to tell you why it crashed exactly, but we would be able to see right here in this session, hey, there was a crash. And if we click through, so there's a link view errors, which would be available for crash as well. That takes us to an environment where we can see all the errors that happened during this individual session. So right now we see that 2 errors happened. And if we switch to the debug view, we get rich metadata on where in the game exactly this failed, which can be connected to your source code. We get the last log entries of what happened when that error occurred. A lot of metadata on what was going on that device, what kind of memory was there, what kind of user was it, and breadcrumbs. Breadcrumbs are system and user events that indicate how did the user get to the error condition. When the game is being automatically tested, that you can see that in the automation testing script. But if it's a manual user or you're collecting this in production from an actual user, this can be really important to point you to the root cause or the steps to reproduce the problem that they were occurring. We have attachments as well. In this case, we've attached a screenshot as well. So you have the ability within the Unity SDK to click a checkbox to capture screenshots in certain situations as well. So this all gives you the rich metadata to resolve it. But let's take a look what Backtrace does for the rest. So we deduplicate in the sense we detect that an error happened on one device, but we automatically have deduplication logic that, as you see, checks if it happened on different hosts. So beyond this test run, we see that it happened on a different machine. And if I select metadata such as the device model, we can see exactly which phones this problem occurred. So it's really easy for me to slice and dice through that data. Right now it's just 2 devices, but even if it's thousands or or hundreds of thousands in production. And I can very easily create a ticket as well. One of the problems that often happens when you're doing game testing and play testing and stuff like that, it's really hard to keep track of what were the problems. What is the information that the developer needs? There's often a cumbersome process to get that information over from the tester to the developer. So in this case, a Jira ticket can be created automatically, can be assigned to a specific person as well. In this case, I assign it to Hunter. And if I open that up, there's all the relevant metadata that's captured in that ticket. Remember, it's a fingerprint across multiple devices, so you get information as well as how many % of the time is it happening on device A versus device B. So rich information that allows you to prioritize whether or not I have to fix this right away. Like I said, you can assign it to specific people that will be synchronized between Jira and Backtrace as well. And you can also say, let's say that we fixed the problem, and we can just say, okay, I fixed it on the latest version. And you can then basically instruct Backtrace and say, hey, if it happens after the version that I currently have, so for example, we're on version 0.9 now. If I say, if I see it again in version 1.0, it will be reopened automatically. So there's rudimentary regression detection as well. So that helps a lot to manage that. So to really summarize, the problems that Backtrace solves during playtesting and QA is just improving the tester's experience so that when a crash happens, the testers don't have to provide a lot of metadata on what happened. The issues are easier to understand because a lot of metadata is captured for you automatically. Triaging is easy because you have to context which devices it happened on, which makes the triage time a lot shorter. So that's the part that I wanted to cover between us and Sauce Labs and Backtrace. I'll give it back to Andrew.
Thanks so much, Vincent. Andrew, just jumping in for a second to say, everybody, don't forget to put your questions. I'm sure there are a few questions popping up in your minds. Don't forget to put your questions in the chat for us, and we will bring you in as soon as possible. Sorry to interrupt, Andrew. On you go. Thanks, Michael.
Yeah, so what we've seen obviously here is gameplay automation and where we can be running in an environment. And now, of course, let's say we want performance metrics. I think it's useful before we even start into performance metrics as to why are we even going down the route of collecting performance metrics. At its core, we have gamers who report issues with games. Now, the way that they're reporting is based off of their experiences with the game. And the way that they report, the way that their experiences work is very subjective. One gamer will say, okay, this is great. The other will say, this is terrible. This is down to, either the skill level of the gamer, how familiar they are with games. It could just be that their perception. So looking at those experiences, we can generally break them down into sort of categories. We can look at fluidity, visual fluidity. So here we're categorizing everything that the gamer sees. And there might also report something on like responsiveness. How long is the game taking to load? How long is it taking us between levels? Are there problems here? Are they having to keep plugging their phone in because they're running out of power? Or is the device getting hot even when running on power? These are all things that are tied to a gamer's senses. These aren't useful for being able to release software. So we need to turn these subjective experiences into measurable metrics. So this is where GameBench comes in. GameBench offers a testing service, and through our own research and experience, we've come up with badges that categorize gaming experience into categories so that we can start to apply discrete values that belong to each experience. So now we're starting to translate gamer experience into categories that we can start to test. Once we have these categories, we can align some of these badges towards different users. So we're looking at ultra performance for a game or on a particular device. We're definitely tailoring here to people involved with esports. It could be that basic performance for an app is perfectly fine for your casual gamer. This is now allowing us to make decisions as to whether a game is good to go or whether there needs to be more work. And these are the important decisions that are coming out of collecting performance metrics. Similarly as well, if you were to take the brand new flagship devices, you would expect to see your game working perfectly fine, ultra badges across the board. If you took a 5-year-old, let's say Samsung device, probably one of the most common device manufacturers out there, would you expect to see the same level of performance on a very high-end game? And of course you wouldn't. So again, here you're making a judgment of what level of devices are we, what tiers of devices are we expecting to cater for with a game? And again, these decisions all have to be driven by data. And without collecting performance metrics, how are you going to inform those decisions? So this is where GameBench's SDK comes in. I mentioned before that GameBench has a manual tooling solution, and that's very catered towards one tester sat down testing a game. But we can't scale that, and we can't do that on a remote location, similar to the GameDriver solution and the error reporting solution from Source Labs. So our SDK supports Android and iOS. We're also Unity verified partners, meaning that Unity verify our solution and are happy to put them on our website and recommend us to Unity developers. But we also have native support for non-Unity games, meaning that you don't have to be developing in Unity, and we know there are a lot of custom game engines out there. From an operation perspective, we have 2 modes. One is an automatic mode, whereby the SDK goes into the game and then it just runs. No additional code required. On the other side, we have a more fine-tuned control, where we do provide an API if you want to take control of how the SDK runs. And from there, you can get additional control over the metrics you record, the areas that you're most interested in highlighting from within your performance session. I mentioned before that we're Unity verified partners, and just to give you an idea of the sort of technical investment required, this is a quick demo of us adding a tarball package to the package manager in Unity. There's no additional steps required. You just need to import the package and then you're good to go. All loaded, all good to go, all ready to start testing. I mentioned about an automatic mode for the SDK. The automatic mode basically starts recording a session, which is what we define as collecting all the metrics that we can record over a time period. And that happens during the on-resume. So we start recording during the on-resume. And then during the on-pause state, or similar life cycle for iOS, we stop recording and we start uploading to our web dashboard, or a private version of our web dashboard. And from there, you'll be able to inspect the data online or pull data down, as I will do a bit later for a quick in control mode. You have control over when the SDK starts and stops, when you want to upload. It could be that you have a particular part of your game that lends itself well to sending data sending data away from the device. And you might want to stack all of your network traffic around that point. That makes sense. We also have fine-grained control of how often you record certain metrics. So it could be that you have critical metrics such as memory. You may be very interested in memory, but from time to time you want to roughly see, let's say, how the CPU is doing or what your rough network traffic is. You could slow down those other metrics while still keeping them recorded, and you would gain the context of information that you need for bespoke for your testing. You will also be able to mark out particular regions. So let's say you started the SDK, you're running, and you want to know, when I'm looking at a menu segment, when am I looking at a gameplay segment, when am I looking at the shop? Each of these three areas have distinctive performance characteristics. For example, the shop, you'd expect network traffic. Gameplay, you might want to be minimizing network interference. Loading screens, you might expect really high network traffic CPU. And it's good to be able to break these down into easily referenceable marked regions. If you want some more information, all of this information is available at docs.gamebench.net. So you can dig through that without even signing up to the SDK and just get a feel for how the SDK works. Once the session is uploaded to our web dashboard, you'll be able to inspect a session. So this is just a singular session, and you'll be able to dive into each of the metrics and go have a look at a chart of where your performance may be faltering, or sometimes just seeing it at overall summary is really helpful. For example, if you're looking to keep your memory budget under a certain value, then right from the summary, you'll be able to pinpoint something that's gone wrong. So I'm just going to jump ahead quickly to a sample. So here what we're going to be doing is going to take a look at the three companies and how we might approach this. Me coming from a developer's background, I always think this is great, but what I really want is just someone to show me one way first before I invest a lot of time into seeing whether this works. So what we've done here is we have set up, first of all, a Git repository with the game that you've been seeing throughout the webinar. And what we're doing there is we're all putting our SDKs in there. So if you want to see an example, a setup for this whole automation, then you can have a look at that at your leisure. If you're starting to look at this from scratch, you'll want to get hold of all or some of our SDKs. You probably want to going to connect this to a CI/CD system and then get some scripts running. In our example, we use a Node.js script that drives the Appium driver. You might use Unity Cloud Build or GitHub Actions. When I'm going to go from the perspective of having GameBench SDK, so from here, once we have the SDK integrated, each time the device is backgrounded on the device farm, then we'll be uploading that data to the web dashboard. And then once we have that, we can start to investigate the results. We can pull that data down and start looking at it on a large scale. When we were running through the sample test data, what we did was we ran the session for 30 seconds just to give us a hint at the data. Now, normally within our labs reports, we run for 20 minutes. It could be that you just want 5 minutes. The longer the session, the better the spread of the data. We're just trying to get sample data. The whole test run took us 3 hours, 30 minutes, and that's perfect for running overnight, over the weekend. We used a 10-second wait to get us into the gameplay before we started recording metrics, just to make sure that we didn't capture any loading screens on slower devices. And then we used an additional 10 seconds at the end to make sure that the data had time to go up to the web dashboard. We did this, of course, because we're on a device farm. We're handing back the device to the device farm. We have no guarantee there as to the processes that will be allowed to continue. So within our test run, we managed to use 162 of Source Labs devices. And here's a rough spread of what we managed to test on. I don't think we hit any limitations. We just stopped at a reasonable amount of devices for our sample test run. All of the sessions were recorded and uploaded to the web dashboard, and then we used our API to pull that data back down into a spreadsheet so I can illustrate to you some of the things that I was looking at on scale. So the things that I was looking for within the data is, first of all, I'm trying to spot those subjective experiences that I mentioned at the start. And also I'm looking for the root cause metrics. So we have the experiences on the one hand, whereby these are the things that the gamers themselves would probably report. And then other metrics are either the cause or back up the reasonings for those experiences. So for example, if your app is using a lot of memory, potentially, you're having to sacrifice other processes, CPU bottlenecks, you're not able to process things as fast, just using way too much GPU, and that's going to affect your visual experience. So initially, I was looking at the fluidity experience. And what I did here, just to get some sample data, is I thought I'll just look at the Google devices. There were lots of Google devices available, and I was curious to see how the Pixel devices actually stacked up against each other. I personally have a Pixel, so this is a bit of just a personal interest on my side. What I could see here was that when I was looking down the FPS column, I was expecting to see each generation of Pixel device to be progressively getting better from a frame rate perspective. If we purely focus on gaming, frame rate is historically always been the core of what gamers perceive as being good. So in my mind, I was expecting from a uneducated perspective, frame rate to be getting better device series on device series. What I actually found was the Pixel 4 was performing better than the Pixel 5. Now I did hear when the Pixel 4 was released and when they did the Pixel 5, that the Pixel 5 was addressing many issues that the Pixel 4 had. Now, this data sort of flips that from a performance perspective in the sense that the Pixel 4 seemingly had better hardware for gaming. Just to line up with what things we expect from the market is we had the Pixel 3a and 4a. Now we know these are the budget models for the Google devices. And again, yeah, we can see a much lower frame rate. And that does align with what we were expecting. It's okay sometimes to find data points that align with your ways of thinking, and it's also good to find problems. And finally, on the Google devices, Pixel 6 device, as expected, was performing really well. Really high frame rate, and one of the interesting things here is the percentage of the GPU being used is significantly lower than the previous generation devices. Now this could lead into something, but first I think we'll probably look at some more data, and then we'll be able to make some sort of a judgment or an area that we can start looking at from things that we can start monitoring week in, week out, and start making improvements.
Andrew, I've got a quick question from the crowd. Hi, everybody. Just to jump in and say, what's the overhead of the SDK of our SDK, and how many megabytes is it adding to my game? And secondly, is it meant to be run in production or testing only? Two questions there.
I don't have the exact figures. We do know it's minimal. One of the things that we do focus on is making sure that the overhead is really minimal on the system. The way that we do that is we have some of our devices, we have a special power setup for the devices. So instead of recording the metrics themselves, because we are in a sense a part of that metric collection, what we do is we take the power reading of the device using basically a hardware setup for recording power. And then we record it with the SDK integrated or with our manual tooling And basically we have a very, very minimal power overhead, meaning that the device is not working any really significantly harder. If you have any questions and you want exact values, please email us at support@gamebench.net and we can get you exact values if that's what you're interested.
And the second question, just while we've got you, is the SDK meant to be run in production or testing only, or across both?
Yes. Yes, all over the place. A or B. Yes. No. SDK is designed to be used out in the wild. So earlier I was talking about the fine-tuning your metrics. So here I think it makes sense that you obviously going to want to tailor your data to exactly what you want live in the field. We have our server, which is web.gamebench.net, which is set up for production SDK. Or if you are running a private server instance, obviously there's a little bit of work on your side because you want to make sure that the data is coming through your networks. But yes, SDK, great for public monitoring.
Fantastic. While we're dealing with questions before we move on, quick one for the GameDriver guys. Hunter and Shane, for the automated testing that Hunter showed, can these tests be run automatically from the CI system?
Yeah, and so what Hunter showed was basically, the manual approach for demonstration purposes of how you would switch between editor testing and running from a command line or shooting it off to run in a Sauce Labs environment. But all of this can be wired up to a CI system, GitHub Actions. That's the intention. Yeah, absolutely.
Fantastic. Thanks very much, Shane. Andrew, sorry to interrupt you. Onward, my friend.
Oh, thanks. So after looking at the Google devices, I then, would naturally think, now let's take a look at the Samsung devices. Probably two of the bigger names in the market. Obviously, we have Huawei and OnePlus, lots of other devices. But looking at the Samsung devices that I'm personally familiar with from personal choices, I started to just have a look at the data. There were lots of Samsung devices. I've selected 5 devices from that list. What I was interested to see when I was looking through the range of devices is how much spread there was in memory usage. So what this table here that we can see has a spread of memory usage, highest values. I've taken the highest value, the lowest value, and some intermediary points through the table. One of the interesting things here is the S9 Plus is actually performing okay. It's using a lot more memory than the other devices. However, it is performing okay. 43 frames per second. It's not 60, but realistically, if you are looking at an old device, you might just want to be beating 30 frames per second. This would be a mid-range spec, a mid-spec device. And so I flagged up the memory. We can come back to that in a bit, just so we can have a look through the data and then see what we potentially might want to do from maybe some budgets or some thresholds that we want to keep an eye on. Taking a look at some of the newer devices. Now the A80 is about 3 years old, but the S21 is the previous generation Samsung flagship device. So having a look here, we're seeing a really good frame rate on the S21. And similarly here, compared to the Pixel 6, so flagship versus flagship device, we're seeing low GPU usage and then seeing a really good frame rate. So now we're starting to see a correlation here. The percentage of GPU being used is corresponding now to a decent visual experience. The A80, although it's 3 years old, still performing okay, but again, not performing as well as the S9, which is surprising considering it's a newer device. Finally, the lower spec devices. Now these have poor frame rate, 6 to 7 frames per second. Game is pretty unplayable at this point. Again, as we see a trend across the board, really high GPU, not using a lot of memory. However, the percentage of the total memory is higher. So, it could be that the device is low on memory itself. What can we take from some of this data? Now, what I might want to do here is set myself a budget on the memory. So here, 777 megabytes of memory is probably a bit high. So what we might want to do is set a budget here on memory, maybe somewhere above the S21, maybe 570 megabytes, and then have devices fail and aim to go below that to see how your performance changes. Similarly with GPU, maybe set a threshold here of failure above 60% GPU. Now, once you change stuff up in the game to keep the GPUs lower on more devices, you're never gonna win every single device. But let's say you're able to get your general performance down across most of the good devices, then you'll have confidence that your target audience will be able to play your game successfully. And this is coming back to now our target audience obviously is the gamers and their experience that has driven us to want to measure something create a measurable value for performance. So we've come from experiences to badges to measurable metrics, and now we can dig in and we can use those measurable metrics to give ourselves some budgets, some goals to aim for within the development testing teams. So you can actually start working towards something and have a measurable point at which you can say that you've achieved what you wanted to achieve for a release. Now, all of this information here is great in a spreadsheet, and so changes that are coming soon into the GameBench offering is we're moving all of this analysis capability into our web dashboard. So you'll be able to view high volumes of data and see where your failures are using the thresholds that I mentioned, and hopefully be able to come in here and pinpoint issues very quickly when we're talking about thousands, hundreds of thousands of sessions, especially when we're talking about a live production SDK. Over to you, Michael.
Thank you, Andrew. That's great. A couple of questions to that. The first one is these metrics that we were just looking at, were they recorded while the GameDriver automation was actually running on these devices? Can you guys clarify that for us?
Yes, the SDKs do run in parallel. I will be completely honest, this selection of data was not run in parallel. However, we have tested to show that the SDKs do work together.
Fantastic. And a second question, we've got a question from Lance Lukens. Christine, could we maybe bring Lance onto the panel, at least with audio, to ask this question, if you're up for that, Lance? And in the meantime, Andrew, I've got another quick question. Does the SDK capture hangs?
Not currently. However, would really like you to drop us an email, either andrew@gamebench.net, and we can discuss that as a feature.
Let me jump in really quick because Backtrace does capture those, so that's another angle that you can use it. I was just also curious if GameBench did it as well, but
Vincent beat us to
Backtrace does.
Okay, Lance Lukens, welcome to the webinar, my friend. You have a question for us, and we welcome it.
Yes, yeah, thank you for unmuting me. So I just had a question about the actual in-network testing ability with the SDK. Is there ability to essentially capture some of the UE network measurements in the logs? So like if you're running these tests from a mobile device, are you on an IPv4 versus 6? Network connection. Are you on 5G? Are you on LTE?
Yeah, I can see Vincent's shot. So currently our SDK only offers sort of the traffic up and down. It seems that Source Labs and Backtrace does have a solution there. GameBench also has a manual tooling that deals directly with network diagnostics. However, currently it's not ready for an automated setup. It's something that's happening really soon. And with that, we can do network latency, network types in the field testing, in lab testing for network optimizations.
Thanks, Andrew. That's great. And Vincent, would you like to speak to the backtrace solution on that at all, brother?
Yeah, I'd love to, because it's actually a functionality that was recently added in the real device cloud. So what happens is the moment that you do any kind of network activity with the app under test, that is captured in Sauce Labs, so you can see the individual web requests. You can expand them just as you would if you do that, like in your browser, in your network inspector. It's based on the same technology, and you can even export the entire thing as a network request archive, so that you can import it in Postman and like debug things that way. So yeah, that's we'll cover IP version 4 and version 5 as well. Response times, latency, these things tend to be recorded there. So yeah, feel free to contact us or like look at docs.saucelabs.com for more information on that.
Okay, thank you.
Thanks for the question.
Sorry, the once a year landline call came through to my phone here in the office just while we were speaking there. Thanks so much for the question, Lance, and guys, thank you both Andrew and Vince for answering that. I'm aware that we are starting to come to the end of our time, and I just want to check whether we have any more precise questions. I want to throw a question out, if I may, to the entire panel, which is really quite a broad question. We've covered the kind of the how of performance automation really thoroughly in this session, and thanks you guys, everyone's done a great job, and I think how the integrated solution comes together is very powerful. Could we just take a step slightly back and say, clearly for QA, the positives of game performance automation are, I think, fairly clear to everybody, and automation is not necessarily always a positive thing in every industry, but for QA and gaming, it seems to be pretty obvious. Is anyone in the panel see any negatives? Are there any assumptions around automation that we should be flagging at this relatively early stage, because this capability has only really now come into the market recently? Are there any negatives that we should be picking up for QA here?
I can add something here, Michael. I think one of the big connotations around automation is that worries people is, I'm going to lose my job because of automation. I don't really think this is the right way of looking at automation. What I'm seeing as from the tech industry is there's always too much work and never enough time. Now, what if you could take all of the menial repetitive tasks and then automate them? Now you are taking your skill set and becoming more of a analytics person, bringing higher value into your teams, as opposed to believing that automation will take your job away. I think there is, me from a perspective, I used to be a developer, so from my perspective there is never enough QA time for a release, for a feature. Now, if you are able to get a little bit of that done automatically over the weekend, overnight, then that's great. That helps developers, that helps the QA teams themselves, and it just gives everyone more confidence in the product as it's leaving the door.
Anyone else? Thank you, Andrew. Anyone else from the panel got a point on that?
Yeah, just a thought on sort of the comment regarding sort of the skill set and providing more value as a tester rather than eliminating tester roles. I mean, we all seen the effects of crunch in this industry, and we really believe at GameDriver that test automation is a part of a solution to that problem, in that there's never enough testers, there's never enough time. The scope of games is increasing dramatically. They're becoming more and more complex and difficult to test across a wide range of platforms and devices. And so what better way to solve that problem and reduce the burden on testing than to provide tools for allowing a tester to scale from what is essentially 2 hands to many hands in being able to execute more tests on a more frequent basis, more consistently. There's so many benefits. The only downside that I've seen from once that is understood and accepted is that then you get the the idea in some areas of management that we can just automate everything. And you're going to reach 100% automation, and you set these really lofty goals for how we're going to get there. And tempering those expectations is really key. The goal is to not automate 100% of the work. It's to automate a percentage of the work that allows you to focus your attention on other things. The things that are really wasting time, you want to get that off your plate. The repetitive tests, the things that are not adding a lot of value, get it off your plate, automate those things. And then you can focus on, is this fun? Is this the experience that we're looking for? You know, how can we improve this? And really elevating the role of QA in an organization.
Shane, when Andrew and I were talking about this a couple of days ago, he mentioned a model that goes back, of course, to the great Donald, or maybe not so great Donald Rumsfeld, the old known knowns, known unknowns, and unknown unknowns. Andrew, do you want to speak to that? Because I thought that was a great way of summarizing how the work gets sliced up when we start to introduce automation.
I mean, yeah. I've been fed this quote so many times in my career, so then it's only fair that I start repeating it. Automation really can be summed up. So if you have your known knowns and you have your known unknowns, and then there are always unknown unknowns. I have to say that nice and slowly because I get lost. So if if what you know is your known known, there's no need to test it. Now, if you know you don't know something, you need to test that because you need to find out what the result is. But you already know how to test that every single time. This is where automation sits in this middle category. There are always unknown unknowns. And this is the true skill set of QA, because any developer will know you hand your software across to QA and they come back and they say, yeah, I took the software, I uploaded it onto a brick and I threw it out the window and it's broken. I'm like, what? How? When? This is the true skill set of QA. They are the best people at breaking your code in ways that you'd never imagined it. And if they don't, then someone else, one of your own customers will. And that's a shame if you haven't respected that from a QA professional.
Well, on that happy note, believe it or not, we are very close to the end, and I wanted to thank everybody. We are at the end of today's session. Thank you in our audience for sitting in and for your questions. And also special thanks to Andrew, to Vincent, to Shane and Hunter for running a great presentation for us. Thank you. And also to Christine Iglesias for running the back office for us. She's done a great job as always. The recording of today's event is going to be shared with everyone shortly in the next few days. And our next Performance IQ webinar, which will run, I think, mid-August, is going to shift focus to another area altogether, but touches a little bit on the point earlier on that Lance raised. We're going to be looking at network performance and gamer experience in the North American market. As you may remember, we ran one of these for the UK a few weeks ago that was very successful. So keep an eye on your inboxes. Thank you again for being here, and we look forward immensely to seeing you again very soon. Thanks so much.
Thanks, Michael.
Thanks, everybody.